Welcome to Module 10, Lesson 2, where we're going to start to discuss the least squares regression line. Take a minute and read over the objectives that you will be learning throughout this lesson. If you need to go ahead and pause it to read them, go ahead and do that. Let's talk about the least squares regression line. So you've probably heard of the line of best fit in your previous classes. Basically what we're going to be doing in AP Statistics is taking more of a statistical look at the scatter plot, which is going to be called your least squares regression line. In the last section, we looked at relationships between two quantitative variables. Our goal when examining these relationships, so we're looking at quantitatives, that means numerical, we need to be able to take an average of them. Our goal was to look for a linear relationship. So the only thing that we care about in statistics is a linear relationship. We're going to be able to take the data, the quantitative data, put it on our scatter plot, and determine how can we summarize what exactly that data means. So if our scatter plot shows a linear relationship, we would like to summarize the pattern of that linear relationship by drawing a line on the scatter plot. That line that you've talked about before was the line of best fit. Now we're just going to call it the least squares regression line. And I'll explain to you why it's called the least squares regression line. The line that we create is the regression line, and it basically summarizes the relationship between the two variables. As one increases, how is the other increasing? As one increases, how is the other decreasing? The regression line has one purpose. The purpose is to use the explanatory variable to help predict the response variable. Because when we create a regression line, we don't have every single solitary x value and the corresponding y value. We use that line to help us make a prediction about our y or our response. When we draw a line on the scatter plot, why exactly is it called the least squares regression line? If you'd like to see a visual, please click on this website. It's actually very interesting to see why it's called the least squares regression line. It's called the least squares regression line for this reason. What we do is we plot our data. So this is the average number of heating degrees per day, and this is the average amount of gas consumed per hundreds of cubic feet. So basically what we did is we have these dots, okay, each of these are my data points, okay, this is a data point right here, this is a data point right here, and this, is the data point right here. Those data points are our observed values. So what that means is I plotted this point, I plotted that point, and then I plotted this point. Then I drew this line to summarize the relationship between those three data points. Our goal, so how did your calculator come up with the least squares regression line? How did we get the equation of this line? The goal is to create a distance a vertical distance from the observed value to the line. Okay, we're going to find that vertical distance, and then we're just going to make a square out of it. So from here, we take the vertical distance from here, make a square out of it. The vertical distance from here to the line, make a square out of it. The goal is to make these squares as small as possible. So I want to make every square as small as possible. So the least squares regression line takes all of these squares and makes the sum of them as small as possible, okay? So it's actually very interesting how that is calculated and why it's called the least squares regression line. Because think about it, if we're using the vertical distance from the observed value to the line, we want that vertical distance to be as small as possible. The closer the points are to the line, the better the line can be used to help predict our response variable. Okay, let's exactly the official definition of the least squares regression line. So number one, it's linear. It's a straight line relationship between two quantitative variables, and it's pretty easy to understand. So a regression line summarizes the relationship between the two variables, but only in settings where one of the variables helps to explain or predict the other. So what we're doing here is we're taking the regression line and we're using our explanatory variable x to help predict the response variable y. So the y is always a predicted value. We don't know for sure because we haven't collected all the data points. It's a predicted value based on a given explanatory variable. So if we notice right here, if we're talking about the miles per driven in a car and the price of the car, okay, so for example right here, this is a data point, okay, this is actually the observed data. Here's my least squares regression line right here. This is what the line predicts, okay? So it's not the actual data point. Here's the actual data point. This is what it would predict. This is the amount of money that we would predict that the car would cost given a certain number of mileage. Now also notice, because not every single solitary miles is part of our data point. So at 100,000 miles, I don't even have a data point, so I would use my line to predict what the car would cost. Okay? Now, if X is the explanatory variable and Y is the response variable for an n number of individuals, in order to get the least squares regression line, we are going to need to calculate the following. Now, you're going to be able to get all of this information from your graphing calculator. A couple of important things about your least squares regression line. The first thing is that you need to get the mean of X and the mean of Y, okay? That ordered pair, the average of X and the average of Y, is always a point on your line. You're always going to get the standard deviation of your X values and your standard deviation of your Y values. And then your R value is going to describe, we'll talk about this later, your R value is going to describe how well the model helps predict your response variable. You always get that from your graphing calculator, and make sure you have your diagnostics turned on in order to get your R value. Here's how we write the equation of the least squares regression line. Now, do you notice something different here? So number one, we have Y, this little arrow means Y hat equals A plus BX. Notice that the Y-intercept is first and the slope is second. I've done a lot of research. I'm not sure why they put the Y-intercept first. I won't take off points if it's written the other way, but just try to write your Y-intercept first. There is a huge difference between Y and Y hat, so it is very important that you make sure that you put that hat on top of Y. The Y is your observed value, so whenever we graphed our points, okay, we had a point, okay, we drew our line. This ordered pair, if this ordered pair was 3, 5, this Y value was what I actually got when I went out and I gathered the data. This Y value right here of maybe 3, 7, this is Y hat, or your predicted value. It's your predicted value because it came from the least squares regression line. So just be careful with that. You have to put that Y hat on top of that to show that it's not one of my data points I collected. It is predicted from the regression line or the regression model that I've gotten from my graphing calculator. Okay, so when writing the least squares regression line, you must put the hat on Y. It tells us that it's the predicted value of Y and that the data is not perfectly linear. So when you have the equation, if you just have Y equals mx plus b, that is telling us that all the data points are perfectly linear. I don't have any data points that were off of the line. So that Y hat tells us, hey, I had, like a scatter plot and I need to make sure that I'm predicting my data. Now, this information right here is actually on your formula sheet, okay, that you can use on the AP exam, this piece right here and this piece right here. So a couple of things I want you to note is, number one, you have Y hat equals A is going to be your Y-intercept, B is going to be your slope, okay? A couple of things. Now, number one, we get our slope by the correlation coefficient R times the standard deviation of Y over the standard deviation of X, okay? The point X bar and Y bar is always a point on the line. So that means that you can plug in X bar and Y bar into the equation to find other values such as the slope and the Y-intercept. So I can replace, you could replace this with Y bar equals A plus B times X bar, and let's say you had the slope, fill in your slope, solve for your Y-intercept, okay? So make sure you understand that. The other thing I want you to notice here is B is equal to your correlation coefficient, the standard deviation of Y over the standard deviation of X. Notice here that R, remember, it measures our direction and our strength, so R is either going to be positive or negative, but standard deviations are always positive answers. So that means that your slope and r are going to have the same sign. So if you have a negative slope, that means r is negative. If you have a positive r value, that means b is also positive, because your standard deviations are always positive and they're not going to influence the sign of the final answer. Okay? All right, so you're going to have to be able to interpret the slope and your y-intercept in the equation y hat equals a plus bx. So let's just do a refresher of what slope means. So slope is predicted. It is the predicted change in y as x increases by 1. So let's just say we had a slope of 2 over 1. And let's say that this was $2 for every mile you ran. Maybe you're running for money. Okay? All right, so you would say that for every 1 mile that you ran, the predicted amount of money would go up by $2. So just be careful that you're using that word predicted. You must include that as part of the interpretation in context, okay? The y-intercept is the predicted value of y when x is equal to 0. Okay, so remember that's always when x is equal to 0. Just be careful with that you're using that word predicted. Correlation and slope are closely connected. We already went over this. If the correlation is positive, then the slope is positive since they both measure the direction. Okay, and we also use r to find the slope. Okay, so what exactly is the standard deviation of y and standard deviation of x? The standard deviation of y is the standard deviation of your y values. Basically, how far away on average do the predicted y values differ from your observed y values? So if you have your graph and you have your line, here is your observed, here would be the predicted. On average, how far away is this predicted value from this observed value? So same thing here, 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 and here. So on average, how far away are they? So same thing with your standard deviation of x. It is how far away on average do the predicted y values differ from the predicted x values? How far away on average do the predicted y values differ from the observed x values? So basically what this means is on average, how far away are the x and y values on the least squares regression line from the observed values you used to create the scatter plot. So it's just saying, on average, how far away are each of these predicted values from the observed values that you gathered. All right, now what exactly is on the AP exam formula sheet? So number 1, this is what it's going to look like. Make sure you include that y hat. B0 is your y-intercept, and B1 is going to be your slope. Okay, you can cross this off of your formula sheet. You're never going to know how to do that. Your calculator will give it for you. And this formula right here is just saying, it's just a rearranging this top formula up here. It's saying here is how you find your y-intercept by taking, notice how it says y bar minus the slope times x bar, and that's because your x bar and your y bar are points that are on the line. And you can get the mean of x and the mean of y and the standard deviation of x and y and r from your graphing calculator to find your b value. This r value is given. You never need that. Cross it off. And then here, this just tells you how to find the slope. All right, so a regression line is a model for the data, just like our density curves were a model for the population. So the equation of a regression line tells us about the relationship between the explanatory variable x and the response variable y. So the equation of the regression line is as follows. So we've already talked about most of this. Y hat equals a plus bx. Now just keep in mind that y is read as y hat. You need to include that hat. A is going to be your y-intercept and b is your slope. Now keep in mind though, once again, y hat, that means that hat actually means predicted. So it's the predicted y value. This y-intercept is the predicted y-intercept, and then this, your slope, is the amount of change predicted by y for one change in x.